Next, let's construct a model where not only are we going to allow the intercepts to vary by state, but we'll allow the slopes with respect to the amount of nitrogen added to vary as well. So what will this model look like? Okay. So we're going to use the same explanatory variables as before, but our model's going to look like this. So this is what we had before, right? And now we're going to add a third term, beta 3 times x1 times x2. This right here is what's called an interaction term, plus epsilon, of course. So this is an interaction term. So you can think of it as, for now, just think of it as the product of the x1 and x2. That's what it is. So it's x1 times x2. Now let's see what the implications of setting up this model are. So if we have, okay, so let's say we've got Illinois. If we have the case where x1 equals 0, so we're doing Illinois again, what does this model reduce to? Okay, we have beta naught plus we have beta 1 times 0 plus beta 2 times x2 plus, now here x1 is 0, right? So 0 times anything is 0. So we have beta 3 times 0. Put it like that. Plus epsilon. So this reduces to beta naught plus, this goes away, and this goes away. So we have beta naught plus beta 2 x2 plus epsilon. Now, if x1 equals 1, corresponding to a Wisconsin, our model then becomes beta naught plus beta 1 times 1 plus beta 2 times x2 plus beta 3 times 1 times x2 plus epsilon. Simplify this a little bit. Beta naught plus beta 1 plus beta 2 x2 plus beta 3 times x2 plus epsilon. So here we have, let's simplify this a little bit more. Beta naught plus beta 1 plus, now here we have both of these terms are being multiplied by x2, so we can pull that out, and we get beta 2 plus beta 3 times x2 plus epsilon. Alright, so let's try to first summarize with words what all of these coefficients correspond to, and then I'll try to draw some pictures that can help you. So what is beta naught? Beta naught is the intercept of the regression line for Illinois, right? Intercept. And beta 1 is the difference in intercepts between Wisconsin and Illinois. Okay, this makes sense because this is the intercept for Wisconsin. It's beta naught plus beta 1, just like we saw before. And so beta 1, since the intercept for Illinois is beta naught, Beta 1 is that difference in those intercepts. Beta 2 is the slope with regards to nitrogen, right? For Illinois. So what would beta 3 be? So beta 3 appears here, right? So the slope with regards to nitrogen, our x2 for Wisconsin, is beta 2 plus beta 3. And the slope for Illinois is just beta 2. So just like beta 1 is the difference in the intercepts between Illinois and Wisconsin, beta 3 is the difference in the slopes between Illinois and Wisconsin. This difference in the slopes with regard to nitrogen of Wisconsin and Illinois. So putting this together, beta naught plus beta 1 is the intercept for Wisconsin, and beta 2 plus beta 3 is the slope for Wisconsin. All right, let's do a little drawing to demonstrate this. So, similar as before, we'll have our x2, which is nitrogen, on our x-axis, and we'll have yield on our y-axis. And we could have, let's say, Illinois here. Let's say that Illinois looks something like this. Too steep. Let's say it looks like that. So the intercept for the regression line for Illinois would be beta naught. This is at 0 here. We'll say this is 1, 2, 3, 4 units of nitrogen. So the increase in yield for a 1 unit increase in x is beta 2. That's our slope for Illinois. Okay? Now let's say that if we were to fit the model, or let's say that for Wisconsin, our regression line looks something like this. So here you can see that the intercept is different. This intercept is going to be beta naught plus beta 1. So beta 1 is if you add beta naught and beta 1, you'll get to this level here. Beta 1 is the difference between the intercept for Illinois and the intercept for Wisconsin. Now let's say that we have this slope. This is the slope of Wisconsin. This, whoa, I've got to do my curly cues better. So this distance here, this change in y for a unit change in x, is equal to beta 2 plus beta 3. So that's the slope for Wisconsin. Okay, so beta 3 is the difference in the slope. And beta 3 could be negative, right? It could be, if you fit the model, it could take any number, so you could have a negative slope. So what you could end up, what this model allows us to see is quite a flexible range of scenarios. You could fit a model where both lines have the same slope. You could fit a model where both lines have the same slope and the same intercept, so they overlay each other. You could fit a model where both lines have, let's say, the same intercept but different slopes. You could have a model where they have different intercepts and different slopes. messy here. All right, so that's what's kind of the neat thing about this. So let's say you were to fit this regression and you wanted to see, is there any evidence that the lines differ at all? What would that look like? Well, since beta 3 is the difference in the slope between Wisconsin and Illinois, and since beta 1 is the difference in the intercept between Wisconsin and Illinois, if beta 1 is 0 and if beta 3 is 0, then you have the same line, this case situation here. So if you want to test the hypothesis, do the lines differ at all? You could set it up like this. You could say, my null hypothesis is that beta 3 and beta 1 are equal to 0, given beta naught and beta 2. So if you don't reject this null hypothesis, then that means you don't have any clear evidence that the lines are different. Pretty cool, actually, I think. This is like a classic hypothesis that we saw with the addition that we could test with the additional sums of squares, right? And now we've reconstructed it to be able to test, is there any evidence that the effect of the relationship between nitrogen and yield is different between plots in Wisconsin and plots in Illinois. Now, if you reject this null hypothesis, you might want to say, well, is it the intercepts or is it the slopes that differ? So we might want to say, do the intercepts do the intercepts differ when allowing the slopes to differ? So, for example, is there any evidence that beta 1 is equal to 0? So remember, beta 1 is our difference in the intercepts. So do the intercepts differ given beta naught, beta 2, and beta 3 are in the model? Or we might ask the question, do the slopes differ when the lines have the same intercept? So here we're not allowing the intercepts to differ. So the null hypothesis would be, is beta 3 equal to 0 given beta naught and beta 2? So this corresponds to the reduced model of y equals beta naught plus beta 2 x2 plus epsilon. And the alternative is that beta 3 is not equal to 0 given beta naught and beta 2. And this corresponds to the model y equals beta naught plus beta 2 x2 plus beta 3 x3. I guess I should get rid of x3 and put x1 times x2 plus epsilon. So here you don't see any beta 1. So we're fixing the intercepts to be the same, but we're testing for a difference in the slopes. So these are examples of some of the hypotheses that you can ask when you set up your regression this way with both qualitative and continuous explanatory variables.